All right, hello ladies and gentlemen, and welcome to your lesson for today. You see that on the first slide of your notes paper, which you should have already, on that first slide you will see the LOT. So please pause the video and attempt the LOT. Try the very best that you can. And when you are ready to check your answers, please resume the video and check your work. All right, welcome back. Let's go ahead and check your work here. On number 1, you should have drawn the line and first subtracted 7 from both sides. N over 2 is equal to 10 minus 7, which is 3. Multiply both sides by 2 to get n equals 6 is your answer. N equals 6. For number 2, again, start by drawing the line. Subtract 8 from both sides to get started. 4m is equal to negative 24 minus 8. They are both negative, so you are actually going to add, and it's going to equal negative 32. Divide both sides by 4. On the left, the 4's cancel. So we're going to get m is equal to, and on the right side, the first thing I notice is that I have a negative and a positive. So I know that my answer with Mr. Multiple Division is going to be a negative, and 32 divided by 4 is 8. All right, the next one, for number 3, I do have to start off by distributing. So 7 times k is 7k, and 7 times 7 is 49. From here then, I do need to subtract 49 from both sides. 7k is equal to 35 when you subtract. And when you divide by 7, k is equal to 5. And once again, I have to distribute here on number 4, negative 18k plus 15, because negative 3 times negative 5 is a positive. Then I have to subtract 15 from both sides. Negative 18k is equal to 87 minus 15. Which is 72. And then 72 divided by negative 18. K is equal to negative 4. All right, so if you still have any questions or are confused about that LOT, sorry about that, you can't hardly see the answer for number 4. It's K equals negative 4. If you have any questions about that, please pause your video and raise your hand, and we will help you out. If you are good to go with that, then let's continue on here for our objective for today. Today, your objective is that you all, the mathematicians in this classroom, can use a trend line to make a prediction from a scatter plot. So you'll notice our level 3, where we want to be by the end of class, is that you can make a prediction from a trend line. The level 4 is that you can write an equation and make a prediction. Level 2, you can do it with some help or some support. And level 1, you're still working at that beginning level understanding. All right, so to get started, there is an explore activity. So I know that this is different trying this in a video lesson. However, I do want you to pause your video, and I want you to try the best you can for at least 2 minutes. Once that 2 minutes is up, or if you would like to try for another minute or so, that's fine. Once your 2 minutes is up, resume your video and I will go over this question for you. All right, welcome back. So hopefully you have tried a couple of things here on this explore activity. If nothing else, you should have put the data points on your graph. That is something that you are able to do by yourself. So let's go ahead and read the question here and see what we can figure out. When a scatter plot shows a linear association, you can use a line to model the relationship between variables. A trend line is a straight line that comes closest to points on a scatter plot. So right there at the very beginning, I'm already seeing that a trend line is not going to touch every point, but it's just going to give me a good idea or be close to the points on the scatter plot. As we talked about yesterday, a scatter plot with those points that do not form a straight line, we can't connect all of the dots with one straight line. So we are going to just get as close to the points as we possibly can. Joyce is training for a 10K race. For some of her training runs, she records the distance she ran and how many minutes she ran. So make a scatter plot of the data. So first I'm going to plot my points. So I have 4 miles and 38 minutes. So it's going to be about here. I'm doing the best I can here with my iPad, so I'm sorry. 2 and 25 is about here. 1 and 7 is roughly there. 2:16. 3:26. 5:55, 2 and 20, 4:45, and 3:31. So again, I apologize. I'm doing the best I can here on my iPad. It is a challenge, obviously, but I roughly have the points here on my graph. So you should have something that looks similar. Yours might actually be more accurate than mine. In part B, it says to draw a trend line, use a straight edge to draw a line that has about the same number of points below as it does above. Ignore any outliers. In this graph, I do not see many outliers. I do not see a point that's kind of way off by itself. If there were a point, let me switch colors here. If there were a point clear out here, the red point I would say was an outlier if that existed, but that does not exist in my data, so I'm just going to continue on here and kind of ignore the outliers because I don't think that there are any. As I look at my data, in order for me to draw an accurate trend line, I want to draw a line that is as close to as many of the points as possible. Okay, so I'm going to draw a couple of lines here and just give you a demonstration. I'm starting with a black line. I'm going to draw a red line. I'm going to draw a purple line. Okay. Now notice all 3 of the lines that I have are going in a direction that's kind of up and to the right. And if you were paying attention to our points before I drew the line, they did all kind of have a positive association, a positive connection there. So my lines, it makes sense that they're all going up somehow. Okay? But which line is the best line? If you'll notice, I'm going to talk about the black line first. The black line is at the top, and it does go through. It actually touches 3 of my points, but it does not have, as the directions said at the bottom, it does not have the same number of points above and below it. It has 3 points on the line, and then the rest of my data points are all below it. So therefore, it's not the best trend line because it does not have the same number above and below. Okay, then let's look down at my red line. That's the one that I drew second. My second line, my red line, does again touch 2 of my points, but then the rest of my points are above it. So it is again not in the middle. It does not have points both above and below. If you take a look at the purple line, the purple line does touch a couple of my points and then has 1, 2, 3 that would be above it, 1, 2, 3, 4 points that would be below it. And you could maybe even count this as a 1 above it as well. So we've got 4 above and 4 below. So you'll notice that that purple line actually kind of goes through the middle of my data. And when I'm drawing a trend line, that is what I want. I want a line that goes through the middle of my data and kind of represents, gives me the trend or the pattern that I see in my data. So in this specific picture that you see, the purple line is the line that I would say is the correct trend line. Okay? Now, with that trend line, I'm going to get rid of a bunch of my extra pieces here. Get that trend line back. So when I look at this trend line, again, I'm not touching all of the points, but I am pretty close to being right down the middle of my points. I've got 1, 2, 3, 4 below. I've got 1, 2, 3, 4 above, and I'm kind of right down the middle there. So as I look at that trend line then, I need to be able to use that trend line to make a prediction. For part C, use your trend line to predict how long it would take Joyce to run 4.5 miles. Well, 4.5 miles is here. So if I follow that up and then over to the left, it would take about 45 minutes for Joyce to run 4.5 miles. Okay, let's continue on here and see if this can continue to make some more sense. How well does your trend line fit the data? So I want you to kind of go back and do some reflecting. Go back and look at the trend line that I had compared to what you have. Was yours close? And what do you think about that? And then in number 2, do you think you can use a scatter plot that shows no association to make a prediction? And for this one, sorry about that, for this one, for question number 2, a scatter plot where the points are just random dots, can you use that to make a prediction? And the answer would be no. You have to have some kind of association to be able to follow the pattern. Okay, so if we just have random points, I could not say, well, if she runs for 4.5 miles, it's this many minutes, because I have absolutely no idea where that trend is taking me. The trend could be taking me up, down, who knows? And so we cannot make an accurate prediction without that trend line or the association shown. Okay, now today you'll notice we did have another piece of finding the equation of that trend line. So you'll notice that this specific scatter plot, it is representing the trend line is already there for us, which is nice, showing us the relationship between the number of chapters and the total number of pages for several books, and then it is asking us to write in the equation of a line. So sometimes after we draw a line, we are asked to write an equation. I know that when I write an equation, I use the format y equals mx plus b, m being the slope, and b being the y-intercept. So I need to find those two pieces. Well, when I look at this graph, I'm going to look for perfect points. Now, it is important when I'm looking for perfect points, I'm not necessarily looking at the dots that are drawn on my graph or that were plotted from my scatter plot, but where does my line cross in the corner of the boxes? And this one, it does cross in multiple places. It crosses down here at the very bottom. And it also crosses at the very next point, and it does appear to actually cross at every corner. So what I can do is I can do one of two things. I can do my y2 minus y1 over x2 minus x1 formula, or I can count rise over run. In this case, because I do have that ability, I'm going to count rise over run because that seems a lot easier to me. So it's important when I look at the rise, I am going up one hop, but I notice that in my graph I'm actually going from 0 to 20. So my rise is 20. And when I go to the side one, or the run of one, it is actually going from 0 to 2. So my run is 2. When I simplify that, it simplifies to 10 over 1, or having a slope of 10. Now I also need to find a y-intercept. I know that my y-intercept is where my line crosses my y-axis. So as I look at that, I do see that my y-axis and my line meet right here at the 0. So my y-intercept is actually going to be 0. So my full equation, y equals 10x plus 0. Now I have some reflection questions. What type of association does my scatter plot show? Well, my scatter plot, as I look at it, my line and my points are generally going in an uphill type of direction, so I have a positive association or positive connection. What is the meaning of the slope in this situation? Well, because I was comparing chapters and pages, I am saying that there are on average 10 pages per chapter. Now that's not always accurate. You'll notice I do have points above and below that line, but on average in the middle of that data, the trend is showing that I've got 10 pages per chapter. At the bottom there, and I know on your screen it is kind of covered up, but you do have it on your notes paper, what is the meaning of the y-intercept? In this particular situation, it's where chapters and pages cross at 0. So if you think about reading a book, you're not going to have read any pages if you have not read any chapters. And so that starting value, the y-intercept, is simply representing that you have read 0 chapters and 0 pages before you have started, or at your starting point here. All right, so go ahead and give this your turn question a try. When you are ready to check your answer, please resume your video and I will go over this question with you. All right, welcome back. The scatter plot and trend line show the relationship between the number of rainy days in a month and the number of umbrellas sold each month. Write an equation. So I'm going to look for slope here. I do see it crosses down here at the 0. Which also tells me my y-intercept is 0, so that's nice. And then I actually do not see another perfect point until all the way almost up here at the top. And so I'm going to count a rise and a run all the way up to there. My rise, it does appear to be counting by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9 appears to be on that line. So I'm going to have 9 over, and my run is also counting by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my slope in this situation is 9 over 10. So I'm going to put that there with my x. And my y-intercept, like we just said, my line crosses the y-axis at 0, so I'm going to put a plus 0. And what do these values mean? The 0, number of rainy days, and the number of umbrellas. Well, if there are no rainy days, you don't need to use your umbrella, and so that's what that 0 represents. But that 9 out of 10 of those days, we are having a rainy day with the use of umbrella needed. All right, so we do have one more quick explore activity here. You are welcome to do this along with me, or if you would like to pause and just give it a whirl and check your answers, you are welcome to do that as well. When you use a trend line or its equation to predict a value between data points that you already know, you interpolate to predict the value. When you make a prediction outside of the data, it is extrapolate. So interpolate is inside the data or inside of the table, and extrapolate is outside of the table. It's extra information. So that's how I keep those two apart. Use the equation of the trend line in example 1 to predict how many pages would be in a book with 26 chapters. First of all, we had an equation that looked like this, y equals 10x. So when we are looking at that specific equation, we are looking at 26 chapters, plugging that in for x. Now, first of all, interpolation or extrapolation? Well, if I'm remembering correctly, there was not a value of 26 anywhere on my table, and so it was extra information, which means it is extrapolation. I'm using my equation or my trend to find extra information, extra data. So in order to find my answer, I actually need to do 10 times 26. So 10 times 26 is 260. So I predict that a book with 26 chapters will have 260 pages. So how many chapters do you think would be in a book of, how many pages would be in a book of 14 chapters? Now, if you flip back actually to example 1, you can look and see that 14 chapters is actually a part of the table itself. So this is interpolation because it is within our data. It's actually on the line. And so we can just follow the 14 chapters line from the bottom up to see that it would be 140 pages. Shows that on the left-hand side. Do you think that extrapolation or interpolation is more accurate? Interpolation is going to be more accurate because it is already within the graph. It fits in the data, and so there's no chance of an outlier or of the data changing when you already have that data, that specific data point even sometimes on your graph. Sometimes with extrapolation, we can try to make that prediction with a trend line, but it is an estimation. It is not always a guaranteed accurate prediction. All right, so for your practice today, instead of doing practice on a worksheet, I am going to ask you to go to IXL and practice this topic. The topic is DD.9, so please make sure you're in 8th grade topics at DD9. And if you get up to 85, the SMART score of 85, raise your hand and let me know if you would like to move on to new topics. If you would like to work your way up to 100 for a piece of candy, you may do so.